Hello, welcome to Team 11's final presentation. My name is Matthew Novaresi and I'll be introducing to you our product, the Hydro Washer. Just to give you an idea of how this presentation is going to go, I'll complete introducing the product by showing you our decision-making process, and then the remainder of the team will go through our individual systems. At the end, we'll conclude with our main points. So, why do we need the Hydro Washer? So, everyone knows Arizona is pretty dang hot. Because of this heat, many people own these pools. Unfortunately, for 3 months out of the year, Phoenix's monsoon season is going to make sure that your pool is constantly full of dirt and debris. So there is a large market to exploit that you need a product to overcome the difficulties and time-consuming process of cleaning your pool. Unfortunately, the options right now are both expensive and there's not very many of them. Some of this competition includes the high-end pool vacuums you can find on Amazon. These are all very high quality, but they charge you around $700 to over $1,000, which is way out of our budget. There's also surface skimming innovations on the market today, but while they are cheap and they do work, they don't work as well as one might like. So our goal as a team is to create a product that will do both. We want an autonomous device that will completely clean your pool at a competitive market pricing. To do so, we started with 5 key systems. We decided we need a power, control, buoyancy, navigation, and cleaning system to properly clean our pool. For each one of these ideas, we generated several concepts. We took these concepts and brought them into our decision-making process. This process is where you assign 4 to 5 design criteria, show the relative value of your system, of those criteria to each other, and then you calculate numbers over all your ideas you generated. So as you can see here, we value price and weight very high for our product, while we said that reliability was a low point of concern for us. The bottom left table is an example of this decision-making process for buoyancy. All of the systems are shown online in our report. After all this concept generation process, we came with this preliminary design. I introduced to you the Hydro Washer. To take you through our first system, here's Mauricio with cleaning.
Hello, my name is Mauricio, and I will give you a brief description of the cleaning system. Basically, the cleaning system consists of the water pump, filters, and a flow reversal valve. To the left, you're going to see an overall picture of the cleaning system and its relative position to the device. Being the heaviest and bulkiest, we decided to place it on the bottom in order to keep the Hydro Washer balanced at all times. The water pump. The design parameters required a water pump with adequate volumetric flow in order to create a large pressure difference, because we're trying to move as much water and debris as possible. Through research, we learned that the average vacuum cleaner generates a pressure difference of about 20,000 kilopascals. Using equation 1, you can calculate the pump head required to create this pressure difference. This turns out to be around 2 meters, but once again, this is only the average vacuum cleaner. Since we want a product that excels over the average products in the market, we decided to go with a pump with better performance at a reasonable price. Our pump is going to be the Jeval DCP8000. It has a pump head of 5.5 meters and it generates a volumetric flow of 8,000 liters per hour. It costs $89, but this is a reasonable price compared to other brands with the same performance. When considering filters, we consulted the National Institute of Standards and Technology. According to them, 86.9% of Arizona dust is 5 microns or larger. Therefore, we needed a filter that would capture debris as small as 5 microns. The filter picture on the left is part of an obsolete system here at AEC where I am employed. Therefore, these filters were free. These filters are 11.7 centimeters long by 7 meters in diameter. Each filter can cover an area of 0.2 square meters. This may not seem like a large number. However, when you combine 4 of them and you assume a layer of 5 millimeters of debris forming around the filters, the area covered increases to 4 square meters or about 43 square feet. In order to make the hydro washer an autonomous device, we needed to find a way of cleaning the filters. We agreed that the best way to do this was to have the flow reverse in the filters and therefore cleaning them from the inside out. However, pumps are not reversible. In order to come up with a solution, we created this assembly right here. It consists of 4 PVC teeth and 2 pistons. When the hydro wash is operating abnormal, water comes through this port and it goes around the filters and it exits on the top port. However, if we move the position of the pistons to a higher position here, the flow will reverse not only inside the valve but around the filters as well. This will clean the filters from the inside out and thus making the hydro washer an autonomous device. That was all for the cleaning system. Now to give you a description of the navigation system, here's Travis.
Hello, my name is Travis Smith and I'll be briefing us on the navigation system. For the hydro washer, we have 2 subcategories for the navigation system. One is while it's afloat, which we're going to have a propeller attached to the rear so that it can move around on the surface of the pool. And the other category is navigation for the ground. For the ground, we're going to have 2 tank treads mounted on the sides of the hydro washer, and all of those will be powered by a motor. To figure out how much power we're going to need from that motor, we first need to calculate the drag. And to calculate the drag, we need to calculate the coefficient of drag. For our calculations, we had a few assumptions so that we could get started. The first assumption is that the water that's in the pool is going to be about 27 degrees Celsius. The velocity of the hydro wash will be 0.4471 meters per second. We're going to assume that there's no friction between the tank treads and the floor of the pool, and that we're going to use an 18-volt motor to power the treads. To get the coefficient of drag, we first need to calculate the Reynolds number. To get the Reynolds number, we need the velocity, the width of the hydro washer, and the kinematic viscosity. After we get all those values and plug it into the equation, we find out that the Reynolds number is 157,000, and that means that it's turbulent flow. Also, what that tells us is that because the Reynolds number is higher than 10 to the 4th, we can use this table provided from our fluids mechanics book. Using this table, we know that we're using a square front for the hydro washer, so the coefficient of drag is 2.1 from looking at the table. Now that we've got the coefficient of drag, we can plug in the other variables such as the density, velocity, and area to calculate the final drag calculation. The final drag is 19.45 newtons, and from there we can get the power required. To calculate the power required, we just multiply that drag force by the velocity that the hydro washer is moving at. Once we calculate that out, we get that the power required is 8.7 watts. Once we have that power, then we can find out how much current the battery is going to be, how much of the battery's current we'll need for the treads. Once we calculate that out, we get that the current is 0.48 amperes. This is a picture of the tank tread kit that we're buying from Bex Robotics. We'll assemble this ourselves and attach it to the sides of the hydro washer. And this is a picture of the propeller modeled in SolidWorks. We're going to print this out and attach it to the rear of the hydro washer. The last analysis that we did for the navigation system was a price and weight analysis. The key components from this was the styrofoam box and the tank tread kits. We're getting 2 tank tread kits and only needing 1 box. And once we calculate all the analysis, we get that the total weight added for the navigation system is 2.96 pounds, and the total cost for the navigation system is about $65 from the budget. That concludes navigation. Up next, we have Oscar with controls.
Hello, I'll be introducing the control system and the power system. First up is the control system. We chose an Arduino Uno because it has built-in RAM on board. We don't have to expand the memory, and we don't have to worry about memory being corrupted or programs being corrupted because of addition of an SD card. We also chose it because there's a vast variety of libraries, which is basically just C files and C programs that were built by users that use the similar sensors that we'll be using. Also, the ability of expanding the board, so we can add attachments to the board to add more motors or add more power to it, so on and so forth. The Arduino will be controlling various motors throughout the whole system and various sensors, which would include hydrosonic and hydromatic sensors. Hydrosonic will be used for a float navigation, which will help with object avoidance and help us from colliding against the wall. Hydrosonic ones will be used for underwater, so we are aware of what location we are currently. And here's a SolidWorks modeling of the Arduino Uno with the screw shield attached, and also the power supply that will be powering the Arduino slowly. We went with this design because we wanted to ensure that the Arduino have power at all times, so there would be no loss of the hydro washer underwater or afloat. Here's a basic layout of my programming for it. Everything will be running on a simple time delay. From the start of the first thing that the user needs to do is press the power button. The hydro washer will wait 5 seconds to ensure that the user has placed the hydro washer into the pool, and after that it will activate the drive motor for the float system, followed by a 15-second delay that will continue to power the float system, and then after that it will switch on the buoyancy system, allowing it to dive for about 30 minutes. For power consideration, considered both like in-wall power and a battery. We considered in-wall because a lot of our higher-end competitors use in-wall power supply, which means they had a cable directly powering the pool cleaner. And this is something that we considered also because there is a low failure rate. The signal outputted by the power outlet is already a sine wave, meaning we don't need to convert it to DC to AC, which is the AC preferable for technology for charging and use. The drawbacks for that would be added weight and complexity throughout the whole system. Adding the cable means we need to ensure everything's watertight. We need stronger motors to haul around the cable. We need a more accurate navigation system to make sure we don't get tangled in the cable. So that's why we ultimately went with a battery for the power supply. For battery, we have made a few assumptions, which is that the voltage would be able to store 18 volts, that the amperage discharge rate would be about 1.5 amps per hour, and that the maximum amps that it will output would be 9 amp hours, and that the total power that we consume by the whole system would not exceed 18 volts. So ultimately, we went with the lithium-ion battery because it's cheaper and it has low maintenance and quick charging rate, meaning that if the user forgets to charge the hydro washer every now and then and it dies, there's no need or worry to replace the lithium-ion battery. If such need does arise, it can be easily bought and replaced without having to look for it too hard. And here's my weight and cost analysis for the control and battery system. As you can see, the heaviest thing on my system would be the battery, of course, and the total price, including the various sensors and miscellaneous things, is $61, and total weight would be about 11 pounds. Thank you. Up next is Alejandro Pisadero, who will be introducing the voice system.
Hi, my name is Alejandro, and I will be talking about the buoyancy system. So the buoyancy system is really important because this is the part of the system that will have the hydro washer either sink to the floor, the pool floor, to clean the debris, and when it's ready to come back up to the surface and skim the pool. So simple buoyancy equation that we all know is it's density times volume to gravity. So for our system, taking all the components into consideration, the weight would be approximately 35 pounds. So if we want our buoyant force to be equal to the 35 pounds, we rearrange it and we can solve for volume, and we get an ideal volume value of 968 inches cubed. By cubing this, we can also find simple dimensions, assuming we want a perfect box for the shape of the system, which is about 10 inches. So obviously, in order for the system to sink when it's ready to go to the ground, weight will need to be added, right, to make the force greater to go down. And for this, we will add 2 piston tanks. So here's a table of different PVC pipe sizes. And I assumed a length of 12 inches for these pipes, and that's how much water these different sizes can carry. So I was able to find the volume from the diameter, and from that, the weight was calculated. And as you can see, there's more weight added to 3-inch diameter or 4-inch diameter PVC pipe. So yeah, we will use a 3-inch PVC pipe size. So if we multiply the weight by 2, that's going to be an extra about 6 pounds added to our system that will help us sink to the ground when ready. So how it works is this system consists of 2 piston tanks. So obviously the piston with the shaft, and it is operated by a motor, so the motor will push the shaft in push the piston in and out. So when the system is ready to flow, the water will be discharged, meaning pushed out by the piston. And when the system needs to sink to the ground, water will be drawn in, sort of like a syringe. The piston will come back and bring in water. So the piston will have rubber O-rings also to prevent water from escaping or entering like other systems, like the electrical components of the hydro washer. So this is an image of the piston tank. On the left is a PVC pipe, 12 inches, and on the right is the piston with a square-shaped shaft. And the reason we did this is so that we can, it's threaded because we're going to mount a gear so that when it's ready to push out the water, it'll push in the stem. And then here's another image of the whole piston tank with the gear, and then with the mounts, it will be mounted to the outer walls of the hydro washer and the inside. And so that's everything for the buoyancy system. And to conclude our presentation, here's Wayne.
Hello, my name is Wayne. So after we combine our all systems together, this picture shows what does our final product looks like. At the bottom, this is our cleaning system, so the water gonna come into the bottom and then come out at this pipe. This is our buoyancy system. The water gonna come in and out at these 2 pipes. This is our control system, this is our navigation system, and this is our propulsion system. So the total dimension of our system is 12 by 10 by 20 inches. You don't need much space to place it. You can put it at anywhere. The total weight of our products is approximately 35 pounds. So it's very easy to move it from your house to the pool. Even the child and teenagers can use that. There are 2 very convenient features of our product, which is self-clean and self-charge. So you do not need to worry about it is low power or it is too dirty to use. You can use it at any time you want. The total cost of our product is $350. So after you spend $350, our products can keep your pool always clean, and you can use your pool at any time you like. So why choose our products? Compare with our competitors. For this picture, this high-end pool vacuum is very large and heavy. Also, this costs a lot of money. For that one, this is called the surface skimming product. Although this product is very cheap and simple, the effectiveness of this product is not as good as our product. So our products combine many advantages of our competitors. So choose our product. You can save time, save work, and save money. So our hydro washer is autonomous device, and it works pretty well for the pool maintenance. Also, the budget is under $600. So our hydro washer have accomplished all the goals that we desired at the beginning. I hope you can like our products. Thank you.